Good morning or good afternoon, everyone. My name is Andrew Sartorelli. I'm product manager for platform here at nTopology, and I'm really excited to get the chance to talk to you today about some of the new enhancements we've added in our latest releases. This is version 2.19 as well as 2.20, which just released on October 15th. And so first up, we're going to go through a few examples of some what I think are really great new capabilities to enhance your ability to create custom blocks. So in this case, we're going to walk through the process of creating a custom drop-down menu within your custom blocks. So we're going to reuse a workflow you may have seen me use in my previous nTop Live, where I'm filtering points based on a volume. And we're going to step through the process now of how I went through and actually created a customized drop-down here. I think another great enhancement to point out that came out in 2.19 is the addition of the custom block manager. So this little icon up here in the upper right-hand corner of the notebook will list the custom blocks that you've added to your notebook, allowing you to have quick access to those. And the other model I'm going to go through is we're actually going to start morphing a seat cushion here. And last time you probably saw me working with a more stochastic structure, right, where I'm morphing the distribution of random points for a Voronoi structure. Well, today we're going to talk about how you can do that with a regular kind of periodic structure and end up with a BCC unit cell, in this case morphed in different sizes based on fields. All right, so let's get started, and we're going to jump into my field block. We're just going to talk through a bit about how this block operates, and then we'll get into the nitty-gritty of creating our custom drop-down here. So what I have here is this filter points by volume block. It takes in a list of points. It takes in an object, and that object is determining how we're going to filter these points. And we can say if we want the points only outside the object, inside the object, or exactly on the boundary of the object. So let's go ahead and let's put that on inside. And what I'm going to do is I'm going to turn off the objects. And now we can see I only have the points that exist within my sphere, within those random points. Now, if I change this to outside, we're going to see a lot more points here, but if we kind of look, we can see that cutout of the sphere here. So again, inside, and we can very quickly see that. So this is all taking advantage of a new block that we've created here, and it's called the choice block. And this choice block allows you to create a custom kind of drop-down menu for your custom blocks. So let's jump into the file. Already got that created and opened up here. And so we can see this is my filter points by volume block. Takes in a list of points and a volume. And now what I want to do is I want to create that choice so that when a user goes to use this block, they have the ability to kind of select through the different options there. So I'm going to go to the Create tab. I'm going to click the choice, and it's going to drop my choice into my notebook, and I'm just going to drag that up into my inputs, and we'll see it now has a description there, a name of choice_0. I'm going to change that, and I'm going to say maybe that's my domain, right? So inside, outside, or on the surface. And so we'll start off with, we'll type inside, and we'll add 2 more inputs, and we'll say outside, and we'll say boundary. Okay, when I import this block now into another document, we'll actually see that instead of this user inputs here, it's actually going to have that drop-down menu. So now let's step through how we're going to add this into my block here. So the way we evaluate if a point is inside or outside is we take our field and we evaluate the distance at each point, those random points. And we know that anything that is negative is going to be on the inside of that object. Anything that's 0 is on the boundary, and everything that's positive is on the outside. So I've gone ahead and I just went ahead and made some Boolean operations here, and these use the less than or equal to, greater than or equal to, or equals to Boolean evaluators. And so we just take that evaluation of the field at each point and we say, if it's equal to 0, or excuse me, less than or equal to 0, then we know it's on the inside. If it's greater than or equal to 0, right, positive value, it's on the outside. And if it's equal to 0, then it's on the boundary. And so we now have a list of these Boolean operations or Boolean values that we can use for filtering, right? Another great block that we've added just a couple weeks ago. Okay, so I've already gone ahead and I've got my little comment here added where it tells me if my selection index is equal to 0, that's going to be inside. If my selection index is equal to 1, it's the outside. And if my selection index is 2, it's going to be on the boundary. So I can just go ahead and start typing domain, right? This is my choice. I'm going to say a point, and we're just going to say selected index. All right. And now whenever I make a choice here and I change the value, if I choose outside, it's going to say my selected index is 1. And so I'm just going to go through and evaluate that multiple times. So I'm going to use the control drag option because I want to use the same value here in my different evaluations, control dragging it into each one. And now I have a Boolean value that tells me if inside selected, if outside selected, or my boundary is selected. And then what I do is I just go through and I multiply this Boolean value, the integer associated with it, 1 or 0, times the value that I evaluated here. And what this allows me to do is, create a full list across all of the points that I want to filter, determining if it's appropriate based on my selection. And so we have the filter block here, and we're just going to go ahead and we're going to select our points as that list that we want to filter. Go ahead and drag that. And now our output, actually, let's change this and say output points so we don't have duplicate names. And this is really the advantage of choice. So if I go back now and I'm just going to open up the file I had before, right, we can see as I make my selections, we're able to very quickly filter out different options. Now, of course, here with the boundary, right, we don't have any points actually exactly on the boundary of our sphere here. All right, so that's the first set of blocks I wanted to talk about. Again, the choice block, which you can find under create choice. We also have this nice select by choice block as well that you can use to automate some of the selection process based on that initial user-defined dropdown, and our nice little custom block manager now that allows us to easily keep track of the custom blocks that we're using within our document. So if I want to go ahead and just remove that, we'll see that if I delete this custom block from my document here, my manager, it's actually going to remove it entirely from my notebook. So I just go ahead and delete that. Now if I delete this, I no longer have that custom block loaded into my library. All right, let's go ahead and take a look at that seating example, and let's talk a bit about how you can create this lattice structure, periodic lattice structure that actually has its kind of cell sizes warped in different directions to allow for different characteristics in different areas. So again, if we think about what we started with in the previous one, we had this Voronoi volume structure, right? A stochastic structure with random points. But in this case, we're going to use our periodic structure. So we'll go ahead and I'm just going to pull out my operation here and talk a bit about the structure we start with, which is going to be, a relatively uniform lattice structure, right? So we go through, again, going through the beta tab to access all of our new lattice blocks. We have the periodic lattice body block, our graph unit cell, and our rectangular cell map. All of these fit within this periodic lattice body block to allow us to generate the structure. So if I wanted to generate a normal, BCC unit cell fit within my volume, here we have it. But in this case, right, as we talked about with the Voronoi structure, I want to have a bit of variation in the structure depending on some performance criteria, right? To try to make sitting in this maybe a bit more comfortable than a uniform structure here. And so to go ahead and do that, we can actually use a new block that we've added called the warp cell map block. So that's under beta, lattice, cell map. And I'm just going to click the warp cell map block. And see, it takes quite a few different inputs here. The first input into this process is going to be our cell map, right? This is what we're mapping our unit cells into. And if I look at what I have for my uniform distribution, right, it's just a regular grid that has no variation, right? It's all fitting to my normal cell size of 10 by 10 by 10. But if we want to introduce some kind of variation in that, right, we can use this warp cell map block. So you would drag your cell map into warp cell map. And now you have some options here in terms of U, V, and W scale. And this is how your lattice is going to change, or your cell map is going to change based off a field. So negative value in these fields mean your unit cell is going to condense. Now positive value means your unit cell is going to expand in size. So let's take a look at the warp cell map that I've already gone ahead and created. I'm just going to isolate that and we'll walk through the inputs. So if you look at it, you can actually see quite a bit of that morphing of or warping of the unit cells in this structure. And so let's talk a bit about how you can go ahead and do that. So what I ended up doing is I created a ramp, and let's take a look at what those inputs for those ramp are. So in my last example, I used the seat modifier, which is just a field to start modifying the distribution of points. So we can take a quick look at that. And I use that modifier then to ramp my output function. So you can see here, here's my seat modifier, and everything that's within this object, right, we're going to be clamped at 0, is going to be at minus 0.2, excuse me. So that's going to condense my unit cells in this area. And then as I get to a 10 millimeter distance from this seat modifier, I'm going to go back to my normal distribution. So we're going to condense on the inside and then expand as we move away to the normal unit cell size. And so I use this same ramp function. Actually, let's go ahead and use Field Viewer and take a look at it. And so let's turn that there. So we can see now what the values are. So on the very inside, it's a minus 0.2. As I move towards the outside, it approaches 1 with a very small kind of ramp in between here. And so I'm going to use this same field, the same ramp, as the U, V, and W scale because I want to change my cell map in all of those directions. So, right, U, V, and W are the local X, Y, and Z of our cell map. So we can go ahead and as we put those fields in, we'll see we end up with a cell map that looks quite a bit different from our original. Right? Here's our original, and now here is our new cell map. And so we can use that cell map in the periodic lattice body block, just like we would the rectangular cell map that we created before. And so now when I generate my lattice structure, we can see there's a lot more variation in the unit cell sizing within this structure. And that's all with a periodic lattice body and not a stochastic one. So I think this is really an exciting new set of capabilities here that allow you to tailor performance in ways that you couldn't before with periodic lattice structures. All right, the last thing I want to talk about here after these two quick examples is I think one of the nicer usability improvements as we've gone through with version 2.20, 2.19, we've improved some of the documentation on our help site. So a number of my colleagues Huge shout out to them. Really adding a lot of technical detail and background knowledge on things like topology optimization, some of our Boolean operations that you can now easily access through the help documentation. In this case, nice little example here telling you about the different boundary penalty methods and the outcomes from using either Neumann or I'm going to pronounce this wrong, a Dirichlet boundary condition within topology optimization and the effects on kind of material stickiness along the boundaries. All right. Well, I want to thank everyone for joining us this morning or this afternoon, again, depending on where you are. And be on the lookout again for our next release, 2.21. I think it's going to be a really great one there. All right. Take care.